Hello, everybody. This is Mr. Slomka, and today we're going to talk about section 4.2, which is going to be a continuation of point slope form. So the point slope form that we have is right up here at the top of the page, and it's going to look this way every single time with the y is equal to at the front and then a whole bunch of pieces after, including the parentheses that we have here around that x minus h. Inside of this form, we have a couple of different details, and I want to make sure that we point these out. So right off the bat, m right here, h, and k are all going to be called constants, or in what would be a little simpler is if those are going to be where the numbers go. So this is going to be a constant. This one's going to be a constant, and so is this one as well. The other two letters that we have are X and Y, and those ones are probably not very surprisingly, those are going to be the variable locations. And so when I say variables, that means that that's going to be a spot where things can change. You can plug in lots of different X values or Y values, and so it's best to leave those as letters. You don't want to replace those with numbers right off the bat. So these ones are going to be where the variables are going to be. Okay, so now I know that you have other tools in your toolbox like slope-intercept form, which is y is equal to mx plus b, or standard form, which is ax plus by is equal to c. And those are really great, but I want you to see if you can try to spend some time with point slope form because I'm going to think you're going to find a lot of great convenience with this. Speaking of which, a lot of that convenience is spelled out right in the name. It's called point slope form because in this form right here, there is both a point and a slope in there. And so I want to see if we can pull that information out. So point. Point is usually an ordered pair, which means you need two things to go in here. And we're going to collect those from here. And we want to make sure that we're collecting constant values. So those are going to be actual numbers. So in here, the two spots that are going to give us our point are going to be these ones, which is going to be our h value and our k value. And the great news is that when you use them, you're going to use them in alphabetical order. So h comes before k in the alphabet, and we're going to write down h before k every time we use them. So that's going to be a little bit nicer. If you want to plot this point on an xy axis, like one of these right over here, you would move side to side to find where your h location is, and you would either move up or down to find out where your k value is. Slope. Slope is probably not very surprising for you as well. Slope is going to be m. Slope has been m for a long time, and that's not really going to change, so we're going to keep it the same just for consistency's sake. Also, for consistency's sake, this idea of h and k being an ordered pair, that's going to be true for the entire rest of your math career. So you can take that and use it when you're in Algebra 2, when you're in pre-calculus, when you're in calculus. It's going to be the same way. It's going to use the same letters, h and k, and they're going to do the same jobs. One other important detail that I want to make sure that we're clear on, and this is probably the most annoying one that causes the most frustration, and that is actually this sign right here. You might notice that everything else in the problem is listed with a positive or no sign at all, but that guy right there gets a very, very specific negative sign, and that's something that we're going to have to deal with and watch out very carefully for. So make sure that you're paying close attention to that. I'm going to bring that up again once we go through a couple of examples. So let's take a look at our first one. So our first couple of examples right here are asking us to just graph, and graphing is one of the easiest things when you have point slope form. A lot of times if you're trying to graph equations, you need to build yourself an XY table. And I know that a lot of people don't like to do that. And so point slope form is really great because you don't need the XY table. You can just jump right into plotting. So I'm going to do that instead. The first things I want to do is I want to see if I can get that point taken care of. And so the point is once again going to be based off of that h value and that k value. And so you can see those two pieces right here. Now, when I pull the numbers out, we don't have to do anything to calculate new numbers. We're just going to use the values that we have. But the one thing that you have to watch out for is, once again, that negative sign that is in front of your h value. So that 4 looks positive, but really what we're talking about right there is a negative 4. So there is a sign change that's happening there. That negative creates that sign change for us. So we're not going to use the 4 as is. We're going to have to adjust it slightly. Say, different for second number, we're going to pull out the 5, and we don't have to do anything fancy with that. It's just going to be 5. Let's plot this point as well. So we're going to go negative 4 units over, and then we're going to go 5 units up. Our scale here on this graph is counting by 2, so make sure you're being careful so that you don't plot it right off the graph. The other thing that we need in this case is going to be the slope, and slope is going to be our other number that we have. And this one's written as a fraction, but that's actually really good news because remember that slope is rise over run. So you want a top number and a bottom number in order to utilize your slope properly. Our slope does have a negative, so make sure you're taking advantage of that. So I'm going to be going down 5, and then I'm going to be going to the right 2. So it's going to be 1, 2, 3, 4, 5, and then to the right 2 is going to give me another dot here. And as I've said many times before, the more dots you make, the better. It would be Foolish to only draw 2 dots if you have room for more. So take that a little bit further if you ever you can. So 2, 4, 5, and then 2 more over. And if you can do it any more, that would be fantastic as well. So you can get a bunch of dots, and not surprisingly, you can see that they all line up. And that's really important because it's supposed to be a line. So there's my line right there. All right, your turn. See if you can try the next one out on your own. Next one can be a little bit tricky because the slope is a little bit strange, but the point starts off very normal. So our point right here is going to be 5 and then -1. Notice the sign change right here for the 5. So make sure that you are using a positive and not a negative. So my point is going to be right here. Slope would typically be located right here, and there is a number there, but you need to make sure you're paying close attention to what it is. That number for your slope value is -1, or if you'd like, it's actually -1/1. So that means you're going to be going down 1 and to the right 1. So we're going to have another point that's going to live right there. And as I said last time, you can continue that as many times as you would like. And in fact, in this case, you actually have enough space to go up 1 and to the left 1 as well, and you can gather more points too. You can definitely see that these ones definitely line up very nicely, and so we can get ourselves a nice straight line for this one as well. Arrows on either end as usual. All right, let's see if we can go backwards now. So for our next example right here, what we have is we've got a graph already, or what we'll have very soon, and then we're going to try to write an equation for it. It says very specifically in the directions that they want the equation in point slope form. This is the type of direction you need to watch out for because you have so many tools in your toolbox. You might be interested in using slope-intercept form or standard form, and when the directions are asking for particular form, I want you to make sure you're sticking with it. So you got to make sure that you are honoring the directions that are printed on the page. So the other information that they give us is right over here. This is in function notation, and I know that some of you don't really like function notation, but I think that that's going to get a little bit easier when you spend more time practicing with it. These things that we have right here are going to be points. This is a point right here, and this one is a point right here as well, and you just need to plot them. The very first value that we have is our x value, and the second one is our y value, so we just need to move side to side using the -4, and then we need to move up and down using the -1. Same thing for this one. It's going to be another x and y combo. So for my first one, when it has -4, -1, I'm going to go 4 units to the left and 1 unit down, and this is going to be my very first point right here. For my second one, which is 6, -5, we're going to go 6 units to the right and then 5 units down, and this is going to be our second point right there. What the question is basically asking us to do is it's asking us to create the equation of the line that passes through these 2 points and is going to look something like this. That's super easy to do with point slope form because the only things you need are some points, and we have plenty of them, and you need slope, which we should be able to get very quickly and easily. So let's talk about slope. To get slope, you could do this in 2 different ways. The first way that you can get slope is you can get it by bunny hopping on your drawing. So if you wanted to, you could bunny hop your way down 1, 2, 3, 4 units. That is down 4 units, so that's going to be negative. And then you'd also have to run over to the right, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That'd be 10 units to the right, which would be positive. You can also get your slope by calculating it because we have a formula for slope, which is y2 minus y1 over x2 minus x1, and it looks like that. All of the y's and x values that we need are right over here, and so you can just pull them from the information. You don't even need the graph if you don't want it. So that could be -5 minus a -1 for our y values. Those are both of the numbers that are at the back. And then you can do the same thing for the 2 numbers that are in the parentheses, which would be 6 minus a -4. Minus and negative in both of these cases are going to turn into plus, so we're going to end up with a couple of plus signs here. And we already have a good idea about the numbers that we should calculate right over here for our graph, and so we're just going to make sure that they turn out the way that we are expecting them to. And we still get another -4 and another +10. Regardless of whatever technique you use for the slope, reducing your fractions is required. You're not allowed to skip that step. I am not interested in your fraction -4/10 unless it is reduced. So make sure that you take it that next step and you reduce it. A good common factor for these guys looks like it's going to be 2. And so we want to see if we can bring that down a little bit. So it's going to be -2/5. That's the best slope right there. Okay, so now the part that some people get a little stressed about is that they know that they need 1 point, but in this problem, I actually gave you 2 points. And so they get confused as to which one would be best. And to be honest with you, I don't really care. So you can pick whatever one you want. So the first point that we were looking at was this one, -4, -1. So if you want to use that one, you can. So if we choose this guy right here, we're going to pair it up with our slope, and we're going to build an equation using these pieces of information. In this case, the -4 is going to be my h, and the -1 is going to be my k. Let's see if we can build that equation. So there's my y is equal to, and here's my slope. I've got my parentheses all set up, and now I just need to fill in my h value and my k value. Remember about the sign change that we keep on talking about with the h. So it was a -4, but we're going to put it in as a +4. And then our k value just goes in the normal way. So it's going to be -1. Okay, so that's a really good answer, and I like it a lot, but it's not the only one. And so if you wanted to, you could use your other point as well. So the other point that we have right here is f of 6, and that's going to be equal to -5. And you can use these two values for h and k as well. And the crazy thing is that this works equally good. There's nothing wrong with the answer. They both are good. So this would also work out great. I'm going to start off with y is equal to again. I'm going to still be using the same slope because it's the same line that has the same rise and same run. I'm going to have my parentheses for my point slope form. And then I'm going to use my h value and my k value. Remember that our h value is going to have that sign change. So it's going to be -6, and then the k value goes in as normal. This is equally good. There's nothing wrong with the top one or the bottom one, and you don't need to write down both. I'm just writing down both so that you can definitely find the one that you felt most comfortable with, but you're not in charge of both. You just have to write down one of the two. So I would love the top one or the bottom one, and it's your choice. All right, your turn. See if you can do the same type of work right down here for this one. This one's already plotted, and so that's going to make your life a little bit easier. Give that one a try now. Here is our final. We're going to have another slope. This time it's -3/8. And so our slope is going to be right here. We have two different points that are provided for us. And so we can use either one. If you use the point -4, the one on the left right here, here is your final equation. Notice that in the equation, it does say +4, not -4. If you want to use the second point, which is 4, -2, here is your equation right here. And this time it says x -4. Both of those are good. You don't need to write down both of them. You just need to write down one. I have provided both so that no matter which one you chose to write down, you're going to see it right now on the page to confirm your work that you did. Last example that I want to talk to you about is our final form. So if you've been looking carefully, we've been talking a lot about equations and lines, and you can see that we've kind of worked that situation both ways. The third representation that's always important to look at is the table. And so right back here, we've got a couple of tables that we want to take a look at. And if you take a look, what we have right here is we've got two tables, and that's because one is good and one is bad. And so what our job here is to do is to identify which table can be modeled in a linear equation, so which one's the good one. And then the second part is to write the equation in, once again, point slope form. You have other forms available to you like slope intercept or standard, but we're specifically sticking to point slope form, so please make sure you honor those directions. Okay, so let's see if we can do the first part. Identify which table can be modeled in a linear equation. Linear equations are going to follow very strict patterns, and they need to be consistent without changing. And so that's going to be our first job. Most of the time, students are pretty adept at just kind of looking at it and tell. And so if you want to go through that, that would be totally fine. As I am kind of bumping along my x values right here, I want to see if I can kind of pick up on what pattern is happening. And these ones all look like they're adding 2 each time. It's a really great pattern, and it looks like it's consistent. Down here in the bottom, there also looks like there is a pattern, but we need to see if we can break it down a little bit. What I'm noticing right here is that we're going from 1 to 2, and then 2 to 4, 4 to 8, and then 8 to 16. That pattern is different because it's not an addition pattern. 1 plus 1 would get us to 2, but 2 plus 2 would get us to 4, and 4 plus 4 would get us to 8, and 8 plus another 8 would get us to 16. It's not adding the same thing over and over again like it was up here. And in fact, this is actually multiplying 1 times 2, 2 times 2, 4 times 2, 8 times 2. And so that's not going to work out as nicely because it just doesn't do the same thing each time. It does it a little bit different each time. So this one is not the same. and that's bad. So this one is the bad one. This is the one that we don't want because it's not linear. We'll save that one for a different day. Our second one might be a little bit better. So as we go bumping along in this one right here, I'm going from 0 to 1, 1 to 2, 2 to 3, and 3 to 4. That's probably our simplest pattern. We're just simply adding 1 each time. For our y values, we're going from 3.5 down to 3, and then for 3 down to 2.5, 2.5 down to 2, and 2 down to 1.5. This is a subtraction pattern, and that's fine because addition and subtraction are hand in hand. They're very closely related to each other, and it looks like we're subtracting 0.5, or if you'd like, a half each time that we are going from one spot to the next. Oops. Minus 0.5, minus 0.5. This is a nice consistent pattern. That's a much better one. That's the one that we want. Okay, great. So now what I really want to do is I want to write an equation for this. So if I want an equation for this, I want it in point slope form. So we want to make sure that we're following the formula that we've been using thus far. That's going to look like this, which means we need a point and we need a slope. So let's talk about points first. In this in this table right here, you're actually given quite a few points. In fact, you're given 5 of them. Now, the funny thing is that you're given so many that can stress some people out. Because you're given 5 points, you can pick whichever one you like the best. You don't have to use any one particular one, and they're all going to work the same. So you're welcome to pick whatever one you like. I noticed that in the past, a lot of times kids want to choose ones that they like better, and so they might pick something that's a little cleaner, like 1-3 right here, or they might pick something like 3-2. Because those don't have the decimals on them. And if you like those ones, that's totally fine as well. But you can also pick one of the ones that has the decimal in it, and that's cool. But let's talk about the other thing we need. The other thing we need is slope. And so slope is not something that you're going to choose. It's something that you're going to calculate. So you can get slope one of 2 ways. So the first way is to think about slope in the same way that we've done it earlier on the page, which is to think about it as rise over run. We've already done a lot of really great work to get these patterns written on here, and they're going to represent our rise values and our run values. But you need to know where each of them comes from. Remember that rise is something that happens vertically, up and down, just like a y value. So your rise value is actually down here. Your rise value is negative 0.5. Your run value is going to be a horizontal movement, side to side, and that's what's going to happen with our x values. And so that would be this value right up here, +1. Okay, so now that's pretty good. Decimals and slopes don't really go well, so I'd prefer it if it was a fraction. And so I'm going to clean that up. I'm sure that you guys know already that 0.5 is the same as 1/2. And so this is actually negative 1/2 over 1, or just negative 1/2. If you don't like that technique, or if that doesn't seem the most comfortable for you, you can use the other slope technique that we've already used as well, which is y2 minus y1 over x2 minus x1. And once again, pick the ones that you like the best. And I know that a lot of people like these ones because they don't have decimals. So if I was going to use the 2 points that I've already identified, I'd use my y values first, which would be 2 minus 3. And then I'd use my x values second, which would be 3 minus 1. And not surprisingly, when you calculate it this way, you still get negative 1 over 2. So your slope is going to be the same no matter what you do. And that slope is going to be part of our final equation. So I'm going to add that in right here. Okay, now what about the back part? For the back part, you can use any combination of x and y values that you'd like. Make sure the x goes in the h spot and the y goes in the k spot. So one of the points that's really nice is this one, 1,3. And so you can plug that guy in. Remember the sign change? That's going to go right here with the 1, but it doesn't go here with the 3. So there's your first one. If you like the other point that we've already kind of identified, which is 3,2, you can definitely use that, and there's no penalty for it. It's a really great point to use. You're going to use your -3 in the front, and then you can use your +2 in the back. In fact, you can use any of the other ones as well. All of those are fine too. So you could use x with the 2 and the 2.5. You could use it with the 4 and the 1.5. And a very interesting one would be if you use your slope of negative 1/2 with the 0 and the 3.5. This last one right here is very interesting because of 2 reasons. Reason number one that it's interesting is that if you actually try to plot the point 0, 3.5 on an XY axis, what you might notice is that 0, 3.5 actually is on the Y axis. It's a Y-intercept. And if you want to, you could simplify this a little bit. X minus 0 is pretty boring, and so that's not really doing so much for us. And so what you could do is you could rewrite that as Y is equal to negative 1/2 X. And then you could put your plus 3.5 at the back. And then all of a sudden you might say, hey, that's actually slope-intercept form. And that shows one of the close relationships between point-slope form and slope-intercept form. They're almost the same, except slope-intercept form just happens to use a very special point, and that special point has a 0 in it. Point-slope form is a little bit more general because you can use any point you want. It doesn't have to be an intercept. And so they're all great. So for point slope form, you're welcome to use any of these 5 answers, and they're all correct. For slope intercept form, it is a bit more specific. It is only that one that is the correct equation right there. Okay, you have a practice assignment. I'd like you to work on that next.